Okay, let's get started. I guess we're live. Can everyone hear me in the back? Cool. So just to make sure you're in the right place, this is a talk about locks. It's mostly aimed at beginners and intermediate DBAs, devs who know enough to type P-SQL and type some SQL commands that know enough to be dangerous and might wonder why their queries are not completing as fast as they think they should. Talk is Creative Commons licensed, and you'll notice that the footer at the bottom of each slide is the link to the actual slide. So if you want to download them now and follow along, that's great. It is a little bit on the verbose side because I tried to make it such that somebody who didn't see the talk can still look at the slides and get something out of it. So bear with me. And with that, let's just jump into the theory of locks. So PostgreSQL has a locking system to basically keep queries that conflict with each other from all happening at the same time. And its locking system is internal to Postgres. So it's distinct from file system level locks, semaphores, other Unix things that you might be familiar with. And also notably, it's distinct from max standby archive delay and max standby streaming delay. If you're familiar with those two gucks from PostgreSQL.conf, those control how far essentially the binary replica can get behind the primary before queries against the replica are canceled and fail. So just to clarify what locks actually are or aren't. And there are a bunch of kinds of locks. There in Postgres land, there are virtual XID locks, which belong to select queries that don't strictly need a transaction. XID is short for transaction ID. There are extend locks for physically extending a table on disk, and page locks that are specific to an 8K chunk a page in the heap. And you basically don't need to think about any of those. This talk focuses on the most common types of lock that you'll run into as a Postgres user, which are table locks and row locks. So what causes locks broadly? Locks are caused by somebody running a SQL statement. The meaning DML, select, insert, update, delete. DDL, like alter table or create table. And very significantly, locks are also taken by vacuum and auto vacuum. And you can also take a lock explicitly by saying, hey, lock table in some mode. And as I mentioned, locks can lock a single row, they can lock an entire table, or they can lock a subset of rows inside a table. Mostly Postgres just does the right thing to lock the minimal amount it needs. So lock modes are a bit confusing. There are a bunch of them. They correspond to different precedence levels. So locks with a certain strength can lock out locks with a different strength, but not locks with a third strength. And frankly, and they have confusing names that don't really mean much, but are named for historical reasons. So frankly, I think it's not worth memorizing them, and it's best to just use the docs as reference. Let me pop out of Keynote for a minute and show you those. So this page, which is also linked to my slides, tells you about the different kinds of locks. Let's see, a good example is share update exclusive, which is taken by vacuums and auto vacuums. Oh, not mirroring properly. I'm not going to try to fix that at the moment. Actually, I am, because I've got some more examples later on. AV folks? Oh. Let's see, can I usefully move along? Yeah, so I have certain things I'm showing that aren't in the Keynote app. So I just want this one. displays.
Yeah. And then arrangement mirror.
Oh, super. OK, so I'll just toggle that as needed. Thanks for pointing that out. So I was talking about share update exclusive, which you would never guess from the name has something to do with vacuums. But it tells you exactly what kind of operations acquire the lock. And it tells you exactly what other kinds of locks are blocked by it. So you can then look at that respective entry in this page and figure out what's locking what. And as I said a bit earlier, Postgres is pretty smart about what kind of locks to take. So for instance, if you're running DDL, you can still do writes on that table, with a few exceptions. If you are running auto vacuum, you can still write the table, read the table normally. If you're writing something, a row, then it can still be read concurrently. And if you're writing if for some reason you're locking a subset of rows inside a table, you can still do normal write operations on the other rows in the table. So that's the theory, basically. I want to get on to practice, and I'm going to basically do this as a series of cases. Question?
You said that you can continue to write when you're doing most DDL, but almost all DDL does take an exclusive lock. So unless all of your concurrent selects are short-lived, then you'll effectively block writes.
OK. So the observation, just for the recording, was that actually most DDL does take access exclusive locks, which will block, exclusive locks, which will block reads. We're going to get to some examples of that in a minute, but that's quite true. Like alter table generally takes an access exclusive lock, which blocks everything. And there's some ways around that, but that's an important thing to be aware of. Any other questions? OK. So actually, a really common cause of locks, people see something that looks like locking behavior, and they're like, oh, which queries are responsible for this? And it's not queries. It's vacuum, auto vacuum, running on its own. And auto vacuum happens to conflict with running DDL on a table. So you can wind up with your migrations backed up behind auto vacuum, especially on a huge table where auto vacuum takes a long time to complete. And that's the point at which some people are tempted to disable auto vacuum. Don't do that. Because you'll get bloat, and more importantly, you can run out of transaction IDs if you do that, and then your whole database will shut down. So don't go there. One solution is actually kind of paradoxically to make vacuum more aggressive so that it takes more resources, more CPU, and it finishes faster. You might want to crank up maintenance work mem or auto vacuum work mem, depending on which version of Postgres you're on. Actually, I have a whole talk about vacuum tuning, which has slides here, so you can reference that URL if you're interested afterwards. Another solution, if you're just having chronically bad vacuum problems that you can't get around it with any other way on huge tables, is maybe think about not having such huge tables. See if you can partition them, maybe use the really nifty partitioning, built-in partitioning support that comes with Postgres 10 and is enhanced in Postgres 11, or archive data to a data warehouse or something like that. And a special kind of auto vacuum that's worth calling out on its own is transaction ID, auto vacuum freeze. You will see this if you do a PS at the Unix command line. You'll see processes whose name contain the parenthesized expression to prevent XID wraparound. That's an auto vacuum freeze. And this is the issue that I mentioned earlier. Basically, Postgres has 32-bit transaction IDs, and it's actually pretty easy to run through all of those without meaning to. So auto vacuum has to periodically recycle old IDs that it can see are no longer being used by any transaction. More details in that other talk I mentioned. The problem with an auto-vacuum freeze significantly is that you can't kill it. These other processes you can terminate and maybe like quickly run your DDL and then let auto-vacuum happen again. You can't do that with auto-vacuum freeze. It'll just immediately come back because it's so important to your database functioning properly. So again, in that situation, the solution is vacuum tuning, usually. Another problem that we've seen quite a few clients run into is you do a select for update, maybe on a certain table, maybe on a table that's being used by a queue. And when you do that, you're saying, all of these rows that I just selected, lock them because I'm going to do an update on them later. And that means that nobody else can do anything with those rows. It essentially serializes writes. Sorry, you can still read them. So that's a great way to kill, the inherent parallelism of Postgres that you might be using a database to get in the first place. Again, it's something that you tend to see when somebody naively tries to implement a queue as a Postgres table, and don't go there. There are all sorts of great queuing solutions in the world. Relational databases are just not really suited to be one. And another problem is you'll see idle in transactions. So what happens in that case is that somebody is calling begin. They're doing some operation that takes a lock, or they're explicitly taking a lock by saying, lock table blah in blah mode. And then they're forgetting to commit their transaction. So it just holds on to that lock forever. And here's an example of that. I'm not sure if that's super readable, but you select star from Peachy stat activity. There's actually a state column. Oops. A state column, and you can say where state equals idle in transaction. And that'll show you, it's not necessarily terrible to be idle in transaction for a short time, because you begin and you want to do a few different operations before you commit. But if you look at that transaction start time and it's really far in the past, maybe you look at the query start time of the last query and it's a pretty basic query, but it would start a long time ago, then that's a big red flag that somebody's forgotten to call commit. And idle in transactions, oddly, sometimes we get clients who are like, oh, well, sure, but what's the big deal? Well, nobody can see your writes because you haven't committed them. And also, it blocks auto-vacuum, which can run into the sort of transaction ID problems I mentioned earlier. So the fix is simply to find the app code that's not calling commit and make it call commit. That can be a bit of a problem, especially if you have a wall between your DBAs and your devs. So one thing you might want to do is just kill all transactions that stay open for longer than a reasonable amount of time. And maybe your devs will pop up and be like, hey, my transaction died. And you'll be like, well, you didn't call commit. Starting in Postgres 9.6 and continuing to future versions, there's a guck for this. It's just called idle in transaction session timeout, and you can set it to whatever. If you're still in the pre-9.6 world, it's pretty easy to write a cron job that queries Peachy stat activity in this way, where, say, transaction start minus now is greater than interval 5 minutes or whatever, and then grab the PID from Peachy stat activity and kill that PID. Don't kill -9 it because you will then be crashing the backend, but canceling it's okay. And if you are not prepared to take the drastic step of saying, hey, I'm going to kill your transactions if they stay open for too long, you can at least log them. Maybe put that information in your monitoring system, alerting system. We've got one. So those are kind of like the, say, maybe 60% of common cases we see that are just dumb little things that if you happen to know the trick, you can diagnose. So let's go into more general things. You have locking in your database. It's not one of those things. You want to drill down and find out what. But before I proceed, I want to ask if there are questions again.
Question.
Yeah.
So, is the lock concept is kind of equal to a transaction concept? Means if there's a lock, there must be transaction. If there's a transaction, must be lock.
Okay, so the question is, can you consider locks and transactions to be logically equivalent? So if there's a lock, does that always mean there's a transaction? If there's a transaction, does that always mean there's a lock? Let me think about that. Does AutoVacuum take a transaction in order to do what it's doing? Does anybody know that offhand?
Any operation is a transaction. Even if you not begin and not commit, then it's like any operation is singular transaction.
Yeah, yeah.
So if you're writing, it's a transaction, even you didn't do begin.
Actually, just the act of starting a transaction takes a transaction lock, I believe.
Okay.
You know, there's different types of locks, and they're on different types of objects. So
Yeah.
they're not exactly equivalent concepts.
Yeah, just to summarize, the observation over here was that if you run any SQL query, it will implicitly be run inside of a transaction. So you can't get away from transactions that way. If it's a SQL thing, then you know it's a transaction. And then Joe was saying that there are some cases where there's not a one-to-one mapping. So thank you for that.
The vacuum cause basically non-transaction too. Because I was thinking because the non-transaction can cause the table not clean. Can the vacuum itself become a non-transaction?
I want to say that AutoVacuum doesn't actually take a transaction, but I'm not committing to swear that. I would have to look that up afterwards. But let's discuss that, maybe in the hallway track. Oops, I actually do have one more common problem. So this is the problem of DDL, which was alluded to earlier. This is actually a very specific DDL problem. And actually, before I explain it, I should ask, how many people are running betas of Postgres 11? Oh, nobody? Oh, that's so sad. Questions of betas or earlier versions. How many people are planning to migrate to Postgres 11 shortly after it comes out? All right, a few people. That's great. Here's another incentive to do so, possibly. There is a corner case where if you alter a table and you add a column that's not null and has a default, then you wind up getting the entire table rewritten because it has to populate that column with the default. And while it's doing so, it takes an access exclusive lock on your table. By default, actually, alter table does take an access exclusive lock. I'm not going to pop over and show you the page, but if you look up alter table on the PostgreSQL documentation, it'll show you for each sort of subcommand what kind of lock it takes. If it doesn't tell you, the default is access exclusive. So, you know, blocking all access to a table while you write out a huge table, again, is obviously a problem. This is fixed magically in Postgres 11. Andrew Dunstan added some code that cleverly stores what the default value should be somewhere else, and if it's not filled in, it just returns it to queries as appropriate. But if you're pre-Postgres 11, like pretty much everyone is now, what you can do is create the column, don't set the default, but don't make it not null, and then backfill the values for existing rows. So maybe grab a batch of 5,000 rows by ID or something and update them, mass update them to set that column value. And then at the end, actually do the set default. Sorry, yeah, you've got to say that for the end. There is one caveat to this, which is that you still can't add a not null constraint without it checking the entire table to make sure that there isn't any column value anywhere that's null. So you might just want to defer that till downtime or something. Okay, so getting back to the sort of more general question of diagnosing lock problems. the first thing you have to ask yourself is this problem I'm seeing really a log problem? And the usual symptom is like my database, everything's slow, but my database doesn't seem to be really doing anything. Query latency is high, but I/O utilization is low relatively. That's kind of the red flag. So maybe the reason nothing is happening is that maybe the reason things are happening slowly is that they're waiting for other things. So there are two basic ways to drill down on these problems. I call them now mode and later mode. Pretty self-explanatory names. Now mode is you do a bunch of, now mode is useful if you have to figure it out now. You've got some kind of emergency. The problem is it can be a little time consuming because what you're doing is you're writing a bunch of SQL that's grabbing stuff out of system catalogs to try to figure out what's locking what. And often the locks are actually too ephemeral for you to write the SQL fast enough to be able to grab that information. So, if you have like a whole bunch of locks that are tens of milliseconds or even hundreds of milliseconds apiece, that can still easily grind your system to a halt, even if they're going by too quickly for you to personally observe. But that said, let's look at how you actually do it. Your basic friends here are the PG locks system catalog and the PG stat activity system catalog. And I'm going to pop out and do some examples here. Hopefully, get my mirroring working. Hopefully, I don't hit the demo effect here. Okay, that looks pretty small. Let's bump up the font size a little. Great. So let's say that I'm doing some manual locking, just for example's sake. And I lock my table. Lock a certain table explicitly, and then have this other window where I want to come along and lock the same table. And I can't. You notice it doesn't return to me my prompt because it's waiting for the lock. I can go into PG stat activity and I can say, show me the process ID, the PID, of every backend where it's waiting on a lock, where wait event type equals lock. And there's just this one. I grab that PID, copy, and paste it. Let's look at the actual relation that it's waiting on, that is the table, which you can also grab from PG locks. Select relation from PG locks where PID equals that PID. Oh, we got multiples. All right, I'm going to cheat because I happen to know that it's this from setting up my example. So then you can go back to PG locks and say, okay, great. So for that relation that I just found, show me the PID of queries that have, where granted is true. That is, queries that have the lock got granted to them. There should be just this one. We go, great, we got that PID. Let's go back to PG stat activity and tell me everything about that particular query. Oops, select PID, that's not so useful. Select star. And then you move on from there. So, as you can see, it's pretty fiddly. Switch back to displays. You have to be a bit of an expert to do this. Oh, there's also a URL here for if you want to grab everything as a snapshot, like you're afraid that between querying one table and querying another table, the thing you're looking for will go away. You can do some funky joins, and there's an example on my blog there. But I don't want to get too bogged down in that. So let me tell you about later mode. The idea here is that you collect a bunch of logs and then you feed them to some program that does automated analysis for you and gives you a nice report. It's easier. You got lots more data than you can observe as a human being. And that's often important because you might not have only one locking problem that's happening. You might want to just look at, say, an hour. Usually an hour is a good amount of locks. And this does catch those ephemeral locks that were too quick for you to observe just using some SQL by hand. And the only downside is that it kind of takes more time to do this because you have to grab the logs in the first place. But that's it. So my usual recommendation is just use later mode. It's super hard to do it the other way. And if you need to use now mode, it's perfectly legitimate to turn on the extra logging you're going to need for those reports, do a little interactive exploration, and then use later mode later. So I mentioned tools that generate reports. Peachy Badger is basically the tool. Some of you might be familiar with Peachy Fuian, which was an earlier tool that did the same thing. Peachy Badger is kind of inspired by that, an improvement on that. And one of the nice things about Peachy Badger is it doesn't just focus on logs. It tells you about things like connections. It normalizes your queries and looks at the top queries that are taking the most time. So probably a lot of you are familiar with the case where you have like 3 queries that are taking 80% of your time. That's something you can see easily in a Peachy Badger report. And that's pretty important because you just guessed that locks are the problem on your database, but your guess might be wrong. Or you might have other things wrong with your database. It's really seldom the case that there's only one thing wrong with your database. So maybe there's some other low-hanging fruit. So some things to be aware of before you flip the switch and start gathering logs. You're going to need enough space. Usually it's a few gigabytes per hour, like in the single-digit number of gigabytes. Sometimes it's in the single-digit tens of gigabytes for busy systems. If you're going to get more than that, you know who you are. But that's usually plenty. If you're on RDS, there's a specific concern where RDS puts your logs and your Postgres data on a single device. So they're competing with each other for not just for your disk space, but for throughput. So watch your IOPS. If you're close to the edge on IOPS and you're having performance problems, you might not want to take this approach. And another thing is if you use rsyslogd specifically, the remote syslogd, make sure that you are not synchronously writing each log line. And the reason for that is that after the query executes, then when you've got full query logging turned on, you've got to log the text of the query for every query. And when you write that log message, if you're doing it synchronously, then you have to wait for it to go over the network and get written before that backend can proceed to the next query. So that is really a performance killer. The thing to look for here is make sure that you have a minus sign before the destination in your syslogd.conf. And that just says don't flush synchronously. So I'm not going to go into too much detail on this, but these are my favorite settings for running Peachy Badger, or for collecting logs to feed to Peachy Badger. Basically says log everything. Log min duration statement equals 0 is the part that says log every statement regardless of how long it takes, a statement, SQL query. Couple that do require notes are, it's nicer to get logs in CSV format, get a bit more information out of them. But if you want to do that, you have to have this setting called logging collector set to on. And an issue with that is that if it's off, in order to switch it to on, you have to actually restart your server. So you take downtime, which is a really good reason when you're setting up a server for the first time to just turn it on. The other thing is there's a value called deadlock timeout. This is used for detecting when you have 2 queries that are deadlocking each other. If the queries last for longer than this many milliseconds, then Postgres will do that check. But that's also the mechanism that it uses to find out about locks and log locks in the first place. It won't log locks that are shorter than deadlock timeout. So you might think intuitively that you want to crank deadline timeout down as low as possible, but there's a pretty significant performance penalty with that kind of lock checking. So, so I actually just recommend leaving it at the default, which is 1,000 milliseconds, 1 second. But it's worth knowing about if that's not yielding you the information that you need. Just be aware of the caveat. And this is how you run Peachy Badger. You don't need all of these options, but I'm pretty fond of the exclude query option because often it's not super useful to see, oh, well, gee, my top queries are commit. And also there's a discard all query that's coming from PG Bouncer. Great. And you can tell it how many of the top queries to show you. That's the top 50 argument there. And I'd like to just quickly take a look at a Peachy Badger report and show you what the different sections look like. I've got plenty of time. So this is from the sample Peachy Badger report on the Peachy Badger homepage. You can see at the top there are all these different sections that I mentioned as being useful. The locks section specifically gives you a roll-up of what type of locks you have, which if you refer back to this table, then you can often deduce what sort of activity is going on. Oops. And it tells you both the queries that spend a lot of time waiting. These are normalized queries. So if they contain parameters, it's abstracted over those parameters. You want to see specific examples with the parameters filled in, you hit the examples button. Not everyone knows about this. Peachy Badger has this great feature where you can just double click on a query and it indents it nicely for you. And then it shows you the queries that waited for the longest time, the individual queries, which is, so you know, maybe you have a single query that takes 2 minutes and that's like the problem from the application's perspective, and that's what you want to drill down on. One thing that it notably doesn't do is it doesn't show you for each query what specific other query is blocking it. So that really is kind of an exclusively like null mode, examine the system tables type thing. But usually in practice you can infer what's blocking what, because you'll see, like you look at the front tables in the from clause and you're like, oh, well, these blocking queries are touching the same tables as these block ed queries. And often the queries are actually the same. So like, for instance, in the select for update scenario that I mentioned earlier, you'll just see a bunch of instances of some select for update query that are all blocking each other and stepping on each other's toes. So that is actually it as far as prepared material that I have. It looks like we've got just about over 15 minutes left for questions and answers. Thank you. Oh, and shameless plug, I'm a consultant. I work for PostgreSQL Experts. If you need help with locking problems or other problems, come see us. Yes, question?
Just an observation I have on the idling transaction. I think that one of the scarier things to me about that is that even if you're going to do it back, you can have unexpected side effects. Like, I think most people, I encounter a lot of people that aren't aware that if you insert a row into something with a unique index and then roll back, like before you roll back and try to have another transaction, you will block that insert. That insert will fail due to uniqueness constraint.
Mm-hmm. Actually, I'm not sure exactly the scenario you're talking about. So you're saying if you have one insert that's in a transaction that ultimately fails and gets rolled back.
That you explicitly roll back.
Oh, they explicitly roll back. Okay.
Say 10 minutes later, like if someone tries to insert that same unique value in another transaction, it's possible for that insert to fail due to uniqueness constraints, even though the other transaction is still open and not committed.
Okay, that's an excellent observation. Thank you. Just to repeat it, the observation was, say if you have an insert that's open for a long time, in a transaction that's open for a long time, it can still block other inserts that are trying to insert the same value that hit unique constraints and fail during the time that it's open. So it's not like rolling it back just makes everything bad that happened from it magically go away. And that's another reason to be suspicious of idle and transactions. Thank you. Oh, sorry. Actually, that jogged my memory about one thing. So just in case you all don't know, Postgres has this wonderful feature called transactional DDL, which is what it sounds like. You can run a series of DDL statements inside a transaction, and then if any one of them fails, you can roll back the entire thing, so you don't end up with like your migration half applied. Anyway, question?
Yeah, I was wondering if you knew of any tools or logging that can tell you exactly what locks were taken by a particular statement, sort of like explain locks or something. I wanted this when I was trying to fix a locking problem, and I wanted to make sure that the blue thing wasn't taking a bunch of locks.
Oh, that's interesting. So the question was, if I'm understanding it properly, is there any kind of tool that you can give it some SQL and it'll tell you exactly what kind of locks it's going to take?
Or did take.
Or did take, like, after the fact? That is the kind of thing that you could get out of the logs, assuming that the lock lasts for more than deadlock timeout milliseconds. Okay, I knew. There's actually a tool that I don't use super often that was developed in my company that may be what you're looking for.
I think you can compile Postgres with if you can compile your own version of Postgres, there's basically a macro that you can define that will cause extra debugging for locks.
Ooh.
I forget what it's called. If you search through the source code, it's not too hard to find.
Compile Postgres with extra debug statements. That's a cool one. I was not aware of that.
I know there are trace probes when you block on a lock. There are no probes for taking a lock.
Mm-hmm.
That was
Oh, GitHub wants me to do like multi-factor authentication. Okay, I don't want to bog things down too much, but I'll show you this tool later on. It essentially logs your locks to all lock activity to a table within your database, and then you can interrogate that table. So it's not as completely automated as you might be wanting, but it's getting there. Other questions?
It's actually called lock underscore debug.
Nope. Yep.
Let's say I have an instance with 2 DBAs, right?
Mm-hmm.
And there is idling transaction on one database. It doesn't have any explicit locks.
Mm-hmm.
It will still prevent me from creating consistent snapshot. Like, let's say starting logical replication clause of another database, right? So in this case, sense, they like have the same transaction space, transaction working space, right?
So the question was, when you have multiple databases in the same cluster, that is the same Postgres server instance, do they share transaction space, for lack of a better word? And I believe the answer to that is yes.
But even if I start transaction without any explicit additional blocking on one database and another database, I still cannot create consistent snapshot, right? Peachy dump will wait, duplication clause will wait.
That's interesting. Well, Peachy dump usually operates on a per database basis, right? So I wouldn't expect a lock in database A to prevent you from Peachy dumping database B. Have you observed that? Replication slots will wait. Yes, I think that's correct. It's off the top of my head. Yeah. Thank you. Any other questions? All right. Well, thank you very much.